The first shell struck at 500 meters and screamed into the sky, leaving nothing but a hair-thin scratch in green paint that you could barely see without magnification. I pressed my palm against the armor plate, still warm from impact, and felt my chest tighten because the metal beneath my fingers was not dented, not cracked, not even noticeably marked beyond that superficial groove where paint had been scraped away by passing steel. The second shell hit higher and sang the same impossible song, Ricochet, the sound of failure echoing across the testing range at Kummersdorf. The third shell, the fourth, each one carving bright arcs through morning air, while the Soviet tank sat silent and unbothered like a boulder in a stream that has watched 1,000 years of water flow past without yielding. By the seventh shot, Oberst Weber had stopped giving orders. He just stood there staring at the target with the expression of a man watching his entire professional life dissolve into mathematical irrelevance. The smell of cordite hung heavy in the cold June air, mixing with diesel fumes from the testing facility generators, and somewhere in that acrid chemical haze was the future. Our future. Germany's future. Already written in angles and mathematics and crude Soviet steel that simply refused to break no matter how many times we told it to. My name is Heinrich Ernst Kniepkamp, and this is the story of how a single captured tank proved that Germany had already lost a war most of us still believed we were winning. June 23rd, 1941. 22 days since Wehrmacht forces crossed the Soviet border in the largest military invasion in human history. 22 days of crushing victories and collapsed defenses, and thousands of kilometers of conquered territory stretching back toward Berlin like a wake behind a ship cutting through water. High Command was already planning victory parades. Officers were betting on how long Moscow would hold out. Weeks maybe, a month at most. The Red Army was finished. Everyone knew it. Everyone except the men who had to fight them. The men who were sending increasingly frantic reports about a Soviet tank that our weapons could not hurt. Reports that were being dismissed as panic, as exaggeration from inexperienced crews facing unexpected resistance, until someone decided to verify these impossible claims. So they captured one of these machines intact and loaded it onto a rail car and sent it to us, to the engineers, to the men who designed German armor superiority, to the people whose job was to prove that our technology remained unmatched, to me. We gathered around it that morning in the testing hangar, muddy, battle-scarred, still smelling of burned oil and combat, a T-34 model 1941, designation unknown to most of us before that day, just another Soviet designation in intelligence files that no one paid attention to because Soviet equipment was always inferior. That was doctrine. That was what we believed, what we needed to believe to justify the war we had started. Then I walked closer and started really looking at it, and the first thing I noticed was the welds. Crude, rough. Nothing like the precision Krupp craftsmanship that German factories demanded. These welds looked like they had been done by farmers who barely understood the difference between good technique and adequate function. The armor plates met at angles that seemed almost careless. Surface finish was rough enough that you could see grinding marks. The paint was uneven. Industrial gray-green applied with brushes instead of proper spray equipment. This was Soviet manufacturing. Brutal efficiency over elegant precision, function over form. Get it done and get it into combat without wasting time on aesthetics that do not contribute to survival. Part of me wanted to laugh because this tank looked like something assembled in a tractor factory by workers who had never built military equipment before, which turned out to be exactly what it was. But I did not laugh long because I had learned years ago that appearances can be deceiving when it comes to engineering. Pretty welds do not win battles. Perfect paint does not stop shells. So I pulled out my calipers and started measuring. Armor thickness on the front glacis plate, the main surface that faces enemy fire in combat. I pressed the calipers against the cold steel and read the measurement. 45 millimeters. I checked it twice to be certain. 45 millimeters. Not particularly impressive on paper. Our Panzer III had 30 millimeters of frontal armor. Our Panzer IV had 50 millimeters, so this Soviet tank fell somewhere in the middle of our existing vehicles. Nothing revolutionary, nothing to justify the panicked reports from the front about invulnerable Soviet armor. I was about to write it off as battlefield exaggeration when I noticed something that changed everything. The angle. The armor plate was not vertical like ours. It was sloped back at what looked like 60 degrees from horizontal, maybe more. I had Weber bring over the angle measuring tool, 60 degrees exactly, and suddenly those 45 millimeters meant something completely different, because sloped armor does not just provide the physical thickness, it provides effective thickness based on the angle of impact. A shell hitting sloped armor has to pass through more material than one hitting vertical armor because it enters at an angle. The mathematics are simple, basic trigonometry that any engineering student learns in their first year, but somehow we had forgotten to apply it to tank design, or maybe we had just never considered it important enough to pursue seriously. The Soviets clearly had no such hesitation. I pulled out my slide rule and started calculating effective thickness against perpendicular impact. The number that emerged made my hands shake, and I recalculated twice to make sure I had not made an error. That 45 millimeters sloped at 60 degrees created an effective protection of approximately 90 to 100 millimeters against frontal fire, depending on the exact angle of impact. 90 to 100 millimeters. Our best operational tank had 30 millimeters vertical, which provided exactly 30 millimeters of protection. The Panzer IV, with its 50 millimeter frontal armor, was only marginally better. This crude Soviet tank, with its rough welds and uneven paint, had armor protection more than triple what our best vehicles offered, and they had achieved it using less total steel than we were using because sloped surfaces are shorter than vertical surfaces covering the same frontal area. Less material, better protection, through nothing more sophisticated than understanding geometry. I called the other engineers over and showed them the calculations. The silence in that hangar was absolute. Someone finally said that perhaps the rest of the tank was inferior enough to compensate. Perhaps the armor was the only good thing about it. We needed to test everything else, so we started a complete technical evaluation. Engine, transmission, suspension, weapons, vision systems, everything that makes a tank functional in combat. And with each system we examined, the picture became more disturbing. The engine was a V2 diesel, 12 cylinders, 38-liter displacement, roughly 500 horsepower. More powerful than anything in our Panzer fleet. But that was not the most important feature. The most important feature was that it ran on diesel fuel instead of gasoline. Diesel is less flammable than gasoline, harder to ignite even under combat conditions. A gasoline tank hit by a shell turns into a fireball that kills the crew in seconds. A diesel tank might burn eventually, but the crew often has time to escape. Beyond survivability, diesel is more fuel efficient than gasoline, better range, and diesel could be produced from the same refineries that produced heating oil for Soviet cities. Dual-use infrastructure. The Germans used gasoline because that was our industrial standard, but gasoline requires higher octane refining and creates supply chain complications. The Soviets had chosen the better fuel for a war of attrition. The transmission was simple, crude even. 4 forward gears, 1 reverse. Heavy clutch requiring significant physical strength to operate. Our engineers pointed out that it was exhausting to use and required constant maintenance. True, but it could be repaired by frontline mechanics with basic tools. You could literally beat parts back into shape with a hammer if necessary. Our precisely engineered transmissions required specialized equipment and trained technicians. In a long war far from supply depots, simple and repairable beats, complex and fragile every single time. The suspension used Christie suspension, an American design that the Soviets had licensed and improved. Large road wheels, long travel. The tank could drive over rough terrain at speeds our Panzers could not match. It could cross obstacles that would stop or damage our vehicles, and the wide tracks distributed weight better than our narrow tracks. Lower ground pressure, better performance in mud, better performance in snow. The Eastern Front was mud and snow. They had designed for their environment. We had designed for paved European roads. Then we examined the main gun, a 76.2mm F-34 cannon. I requested the technical specifications from intelligence archives. The ballistic performance data made me physically ill. This gun could penetrate the frontal armor of any operational German tank at 1,500 meters. 1,500. Our Panzer III mounted a 50mm gun that needed to close to under 300 meters to have even a theoretical chance of penetrating a T-34. Under 300 meters. Do you understand what that means in tactical geometry? No. Let me show you instead of telling you. The T-34 sees a Panzer III at 1,500 meters. Maximum combat visibility distance in open terrain. The Soviet tank can fire and destroy the German tank immediately. The German tank cannot hurt the T-34 at that range, so the German tank tries to close distance. As it moves closer, the T-34 continues firing. Each shot has a high probability of penetration. The German tank reaches 1,000 meters, still cannot penetrate Soviet armor. The T-34 keeps firing. 800 meters, 600, 400. At 300 meters, the German gun finally has a marginal chance of penetration if it hits the perfect spot at the perfect angle. But by this point, the T-34 has fired perhaps a dozen shots and only needs to land one. The German tank crew has to close to suicide range while being shot at by a weapon that can kill them at any moment. That is not combat, that is execution. We took the T-34 to the firing range because numbers on paper can lie, and metal under stress tells truth that calculations sometimes miss. Loaded our standard 37mm Pak-36 anti-tank gun, the same weapon that formed the backbone of German anti-tank doctrine. The same gun that had dominated Poland and crushed French armor and proven itself across Europe as reliable and effective. 500 meters distance, standard combat engagement range, clear weather, optimal conditions. I gave the order to fire expecting to see penetration or at least significant deformation of the armor plate. The gun crew was confident. They had trained for years. They knew their weapon. They knew what it could do. The shell hit the front glacis with a sound like a church bell being struck, bright metal on metal, and then the shell was gone, not embedded, not stuck, just gone, screaming off into empty sky trailing smoke. A ricochet so clean it looked like the armor had actively rejected the shell rather than merely deflecting it. The impact point showed a scratch, just a scratch, surface deep, meaningless. Weber stared at the target. At his gun, back at the target. He ordered another shot, same result. Louder impact. Another clean bounce. Another harmless scratch. Third shot. Fourth. Fifth. Each one painting bright arcs through morning air, like some kind of mathematical demonstration of futility. Each impact sound echoing across the range, mixing with the smell of propellant and hot brass, and the growing realization that everything we thought we knew was wrong. By the seventh shot, Weber was no longer giving instructions in that confident parade ground voice we were used to hearing. His orders came out quiet, almost questioning, as if he was hoping someone would tell him this was a trick, or a mistake, or a dream. 20 years of service, 2 decades perfecting anti-tank gunnery, calculating penetration tables, training crews, writing doctrine that infantry officers memorized and followed. And 7 shells bounced off that Soviet tank like children throwing pebbles at a fortress wall. I watched his face, and I saw his entire career becoming obsolete in real time. I saw the moment he understood that the weapon he had dedicated his life to mastering could not defeat this enemy. That understanding is a kind of death. Not physical death, but professional death. The death of purpose, and it was written in every line of his face. We changed tactics, tried firing from different angles, from closer range, from elevated positions, used different ammunition types, armor-piercing, high explosive, everything in our inventory. We counted every hit, kept detailed logs because this would need to be reported and High Command would demand exact numbers. 29 direct hits before we finally stopped the tank. 29. And we did not stop it by penetrating the armor. We stopped it by destroying the track mechanism. Shot the tracks off. Immobilized it. But immobilizing a tank is not killing a tank. The crew would still be alive. The gun would still work. An immobilized T-34 is still a fortified position that can fire back. And even immobilizing it required 29 hits. 29 shots to disable one tank. In combat, you do not get 29 shots. In combat, you get maybe 3 before return fire destroys your position or forces you to retreat. 3 shots. And all 3 would bounce off harmlessly while the T-34 methodically destroyed your position. The strategic implications were overwhelming, but we continued the technical evaluation because engineers solve problems and maybe there was something we were missing. We inspected the interior space. Cramped, even more cramped than our tanks. The crew positions were uncomfortable. 4 men instead of 5. No radio operator because they used simpler radio equipment. The vision systems were poor. Small viewport slits that limited situational awareness. The commander had no cupola or dedicated position. Fighting compartment was loud and hot and miserable. Our engineers noted all of these deficiencies carefully, wrote them down, documented everything that was worse than German designs, and missed the point entirely. Because everything they noted as a deficiency was actually a feature. Cramped interior meant smaller target profile. Smaller target is harder to hit. 4-man crew instead of 5 meant fewer people to train. Simpler to replace casualties. No dedicated radio operator meant 1 less specialized position. Anyone could be trained faster. Poor vision systems meant less complex manufacturing, faster production, lower cost. Everything that made the T-34 worse for individual crew comfort made it better for mass production warfare. The Soviets were not trying to build the best tank for 5 men. They were trying to build adequate tanks for 5,000 men. That distinction matters more than anything else in industrial warfare. General Heinz Guderian arrived on the 4th day, the father of modern armored warfare, the man who had written the book on panzer tactics, who had proven that massed tank formations could shatter any defensive line, who had led the drive through France that broke the Allied armies in weeks. He arrived unannounced with a small staff and requested to see everything, so we showed him the measurements, the calculations, the test results, the ballistic data, the photographic evidence of shells bouncing off like raindrops on glass. He read our technical report in complete silence. 27 pages of documentation, graphs, tables, comparative analysis. I watched his face while he read and saw nothing. No expression, no reaction, just focus. When he finished the last page, he set it down gently on the table and asked to observe live fire tests personally. We set up the demonstration, loaded a fresh Paquet 36, 500 meters. Guderian stood behind the gun crew with binoculars watching the target. I gave the order to fire. Impact, ricochet. The shell tumbled across the range, leaving a trail of smoke. Guderian said nothing. Second shot, impact, ricochet. Third, fourth, fifth. After the 10th shot, he lowered his binoculars and walked to the impact zone, examined the armor plate himself, ran his hand over the shallow scratches, pressed his palm against the cold metal the same way I had done days before, stood there in silence for perhaps 30 seconds that felt like much longer. Then he turned to face us, and I saw something in his eyes that I had never seen in a German general before that moment. Not anger, not frustration, not even disappointment. Fear, pure, undiluted, mathematical fear. The fear that comes from understanding that you have started a war against an enemy whose industrial capacity you cannot match. The fear of absolute certainty, of knowing you are going to lose not because you lack courage or skill or will, but because the mathematics are impossible. That evening we gathered in the officer briefing room at Kummersdorf. Large room, oak table, maps covering every wall showing the advance into Soviet territory, pins marking divisions, arrows showing attack vectors, thousands of red markers indicating destroyed Soviet units, hundreds of black markers showing captured cities, the visual representation of victory, unstoppable momentum, the rapid collapse of enemy resistance. Guderian stood at the front of that room beneath maps that declared triumph, and he spoke words that made every sound in that space stop. He said the reports from the front line were accurate. He said T-34s were destroying our vehicles from ranges where our return fire was ineffective. He said German anti-tank doctrine needed immediate and complete revision. And then he said something that turned the room cold. He said we needed to calculate Soviet production capacity, not how many T-34s existed now, how many they could build per month, per year, for the duration of the war. Because if they could produce these machines in significant numbers, then the entire strategic picture changed. Intelligence officers brought files within hours, production data from captured factories, interrogation reports from Soviet prisoners, aerial reconnaissance photographs of industrial facilities, economic analysis from before the war, everything available about Soviet manufacturing capacity. Analysts worked through the night building models, making estimates, calculating possibilities. Conservative projections suggested Soviet industry could manufacture between 12 and 15,000 T-34s per year. 12 to 15,000. The number hung in the air like smoke that would not dissipate. Germany was producing approximately 3,000 total Panzers across all models annually. 3,000. 1/5 the Soviet capacity, 1/5. And that was conservative estimates. Optimistic estimates suggested the Soviets could potentially reach 20,000 per year if they fully mobilized their industrial base. 20,000 against 3,000. That is not a production gap. That is an industrial chasm that cannot be crossed by determination or will or superior training. But the mathematics became even worse when we examined manufacturing costs. Intelligence had captured Soviet accounting documents from a tank factory in Kharkov. The T-34 cost approximately 160,000 rubles to produce. We calculated conversion rates, roughly equivalent to 140,000 Reichsmarks. Our Panzer III cost 200,000 Reichsmarks. Our Panzer IV cost 250,000 Reichsmarks. The superior Soviet tank was cheaper to build than our inferior vehicles. How is that possible? How does an enemy with supposedly primitive industry produce better equipment for less money? The answer was in the design philosophy. They optimized for manufacturing efficiency, used simpler components, reduced unnecessary complexity, accepted rough finish if it did not affect function, prioritized quantity over individual quality. While we pursued perfection in every weld and perfect surface, finish on every component, the Soviets pursued adequate function, delivered quickly and cheaply. The fuel situation made it worse. T-34s ran on diesel. Simple diesel that could be refined from crude oil with basic processes. The same diesel used in tractors and trucks and locomotives throughout the Soviet Union. Single fuel type for military and civilian applications. Simplified logistics, shared infrastructure. German tanks ran on gasoline requiring higher octane ratings than standard civilian fuel. Separate supply chains, dedicated refining. In a long war across vast distances, fuel logistics become the limiting factor. The side that can refuel easily wins. The side that needs specialized supply chains loses. Another point where Soviet design proved superior through simplicity rather than sophistication. Maintenance analysis was equally damning. The T-34 transmission could be repaired by any competent mechanic with basic tools. You could fix field damage with hammers and welding equipment available at any workshop. The suspension was simple enough that replacement parts could be manufactured locally if supply lines were cut. German Panzers required specialized parts machined to exact tolerances, required trained technicians, required equipment that did not exist outside established workshops. In theory, our precision engineering provided better performance. In practice, it meant our tanks stayed broken longer. In extended combat far from supply bases, reliable beats precise. repairable beats, perfect, every time. We calculated crew training time. The T-34 required approximately 3 months to train a competent crew. Simple controls, straightforward operation, minimal specialized knowledge. German Panzers required 6 to 9 months to train crews to full proficiency. Complex systems, precise procedures, extensive technical knowledge. In a war of attrition where casualties mount quickly, the side that can replace trained crews faster has overwhelming advantage. The Soviets could train 2 or 3 T-34 crews in the time it took us to train 1 Panzer crew, another multiplier effect compounding the production advantage. Someone suggested that perhaps German tactical superiority could compensate for numerical inferiority. Perhaps better training and coordination and doctrine would allow our forces to destroy multiple Soviet tanks for each loss, perhaps. Battle reports from the front suggested experienced German crews were indeed achieving favorable exchange ratios when they could maneuver and choose engagement conditions. But those reports also showed that numerical superiority eventually overwhelmed tactical advantage. A skilled crew destroying 3 T-34s before being disabled is still a German loss if the Soviets have 5 more waiting. And they did. They always had more waiting, because industrial capacity converted directly into battlefield advantage. I proposed a radical solution. Copy the T-34 directly, license the design, reverse engineer every component, install it on German production lines immediately, produce 20,000 of them. Forget pride, forget doctrine, forget the idea that German engineering must always lead. Just build what works and build it in numbers that match the enemy. The room fell silent when I finished speaking. You could hear breathing, the scratch of pens on paper stopping. Outside wind rattled windows, but inside was absolute quiet. Guderian looked at me for a long moment. Then he said that High Command would never approve copying Soviet designs. German pride would not allow admitting that enemy technology was superior. Political leadership demanded proof of Aryan superiority in all fields, including engineering. We could not simply adopt Soviet solutions, no matter how effective they proved to be. So instead, we would design a German answer to the T-34, take the lessons learned, apply them to German engineering philosophy, create something that matched Soviet capability while maintaining German superiority in finish and precision. It would take time, extensive testing, careful development, perhaps 2 years before production could begin in meaningful numbers. 2 years, during which the Soviets would produce 30,000 T-34s while we produced 6,000 tanks total. The arithmetic of that delay meant defeat, clear mathematical defeat. But arithmetic does not override ideology. Doctrine does not bend to reality when reality contradicts belief. So we would design the Panther, a magnificent tank, perhaps the best tank of the entire war. But it would arrive too late and cost too much and require resources we did not have. Autumn came, and the snow and the mud and the reports from the Eastern Front validated every calculation we had made in that testing facility. Panzer commanders were radioing desperate messages about T-34s appearing in groups that our doctrine had never anticipated. 10 tanks, 20 tanks, sometimes 50 in a single engagement. Our crews would destroy 3 or 4 and feel victorious until realizing that 15 more were maneuvering around the flanks. Numerical superiority, compounding tactical advantage. 1 hit from a T-34 destroyed a Panzer. 7 or 8 hits from a Panzer might eventually disable a T-34 if the crew lived long enough to fire that many times. The exchange ratio was unsustainable. Anti-tank gun crews were sending reports that made commanders question their sanity. Pak-36 batteries firing dozens of shells at charging T-34s and watching them all ricochet harmlessly while the Soviet tanks drove through positions, crushing guns under their tracks. Entire defensive lines collapsing because the weapons issued to hold those lines could not stop the enemy. Infantry units requesting new anti-tank weapons. better anti-tank weapons. Any weapon that could actually hurt a T-34 from a range where the infantry could survive. But we did not have those weapons in quantity. We had drawings, plans, prototypes, nothing that could be issued to frontline units in numbers sufficient to matter. Wehrmacht issued emergency tactical doctrine revisions. Do not engage T-34s frontally. Maneuver for side or rear shots where armor is weaker. Use combined arms tactics. Call artillery. Request air support. Basically every instruction except the one thing armor is supposed to do, which is fight other armor directly and win through superior firepower and protection. We were telling panzer crews to avoid the primary mission of a tank, to survive by running away. That is not doctrine. That is admission of inadequacy, but it was the only honest advice we could offer given the equipment imbalance. Some crews got creative, started carrying satchel charges and improvised explosives, trying to close to point-blank range and manually place charges on T-34s. Suicidal tactics born of desperation. Sometimes it worked. More often the crew died without disabling the target. There were reports of soldiers climbing onto T-34s to try to force grenades into vision slits or engine grills. Reports of men dying under tank tracks because that was the only way they knew to fight back. Reading those reports made me physically sick because I had measured the armor that those men were dying against. I had calculated the impossibility they were facing, and they were facing it because we had started a war without understanding what we were fighting. We accelerated development programs, rushed new weapons into field testing. The PAK-38 50mm anti-tank gun entered service, better than the PAK-36. Could theoretically penetrate a T-34 from 500 meters with good ammunition under optimal conditions. Better, still not adequate. The PAK-40 75mm was pushed through approval. Heavy, difficult to move, expensive, but it could reliably penetrate T-34 armor from reasonable combat ranges. Finally, a weapon that worked. Except production was slow and prioritization was confused and ammunition supply was inadequate. Having a weapon that works does not help if crews do not have it or cannot get ammunition for it. Tank development programs multiplied. Better guns for existing panzers, thicker armor packages, new vehicles entirely. The Panzer IV received a long-barreled 75mm gun that finally gave it parity with the T-34. Existing Panzer IVs were retrofitted when possible. New production incorporated the improved design. Finally, we had a tank that could fight T-34s on relatively equal terms. But production numbers still lagged Soviet output by factors of 5 to 1. Equal quality with 1/5. The quantity is not a winning formula. Then came the Panther, the German answer to everything the T-34 represented. Sloped armor copying the Soviet geometry. 75mm high-velocity gun that exceeded the T-34's firepower. Excellent mobility, superior optics, better fire control. Refined everything about the T-34 concept and built it with German precision engineering. A magnificent vehicle, arguably the best medium tank of the entire war. And it arrived in spring of 1943, nearly 2 years after we had tested that captured T-34. 2 years during which the Soviets had produced approximately 30,000 T-34s. 30,000. We produced about 6,000 Panthers total across the entire war. 6,000 against 30,000. Mathematics that cannot be overcome by superior individual capability. The Panther also cost approximately 3 times what a T-34 cost to manufacture. Required skilled labor that we no longer had in sufficient numbers because those workers had been conscripted or killed or were working in factories that had been bombed. Required specialized components that took months to produce. Required maintenance that front-line units struggled to provide. The Panther was mechanically complex, over-engineered in ways that caused constant breakdowns, transmission failures, final drive failures, engine fires, superior in every specification, inferior in reliability. In a long war, reliability matters more than peak performance. The tank that breaks down before reaching combat is worthless regardless of how good it is when working. Meanwhile, T-34 production kept increasing. The Soviets moved entire factories east beyond German bombing range, evacuated equipment and workers to the Urals, established new production facilities in areas we could not reach, continued manufacturing through conditions that would have stopped German industry completely. There are photographs from Soviet factories showing T-34s being assembled in unheated buildings during winter. Workers building tanks in temperatures cold enough to freeze metal. Building them anyway because the front needed them. That kind of industrial determination cannot be matched by precision or quality or sophisticated engineering. It can only be matched by equivalent production, and we never achieved equivalent production. By 1944, Soviet tank production exceeded German production by factors approaching 10 to 1. 10 to 1. Even accounting for superior German training and tactical doctrine, a 10 to 1 numerical disadvantage cannot be overcome. The mathematics are absolute. One German tank crew might destroy 3 Soviet tanks before being disabled. The Soviets have 7 more. That crew is still dead, and that tank is still destroyed, and the numerical advantage has barely decreased. Repeat that calculation across thousands of engagements and the result is inevitable. Germany loses. Not because of lack of courage or skill or will, because of arithmetic. There were proposals to simplify German tank production, reduce quality standards, speed up manufacturing, build adequate tanks in large numbers rather than perfect tanks in small numbers, accept rough welds if they did not affect structural strength, use simpler components, prioritize quantity, basically adopt Soviet production philosophy. Those proposals were rejected. German engineering pride would not permit it. We would build the best tanks possible, even if it meant building fewer of them. That decision doomed us, but ideology rarely yields to practical necessity. I think about that day in June 1941 more often than I think about anything else from the war. The moment 7 shells bounced off that captured T-34, the sound of each impact and each ricochet, the smell of propellant hanging in cold air, the expression on Weber's face as he watched 20 years of expertise become obsolete in under 5 minutes. The weight of the slide rule in my hand, calculating effective armor thickness, and knowing before I finished that everything we believed was wrong, that moment contained the entire war, the victory, the defeat, the years of suffering, the millions dead. All of it was already decided in that moment. We just did not know it yet, or refused to know it, or knew it but could not speak it because speaking truth about losing was more dangerous than dying. Some historians claim Germany lost at Stalingrad, where an entire army was encircled and destroyed. Others point to Kursk, where the last major German offensive was broken against Soviet defenses. Some cite the Allied invasion at Normandy, or the bombing campaign against German industry, or the failure to capture Moscow. Each argument has merit. Each identifies a turning point where victory became impossible and defeat became inevitable. But I know the truth that those historians miss, because they were not there. They did not press their hands against cold Soviet armor and calculate the mathematics of our defeat. Germany lost the war at a testing facility in Kummersdorf, when engineers measured a captured T-34 and understood that we had invaded a nation whose industrial capacity we could never match. Everything after that moment was just fighting to delay the inevitable, dying to postpone the obvious conclusion, sending millions to graves because admitting defeat earlier would have been politically impossible. The T-34 taught lessons that went far beyond armor thickness and gun caliber and production numbers. It taught that ideology cannot override mathematics. That belief in superiority does not create actual superiority. That pride is not a substitute for capability. That wars are won by nations that understand industrial reality better than they understand propaganda. The Soviets understood this. They built adequate tanks in overwhelming numbers. They accepted rough welds and crude finish because those things did not affect combat effectiveness. They prioritized function over appearance. They optimized for mass production rather than individual quality. They won because they understood that sometimes good enough at massive scale defeats perfect in small quantities. Not sometimes, always, every time, without exception. That understanding won them the war. Our refusal to accept that understanding cost us everything. I am 93 years old as I speak these words. Most of the men I worked with are dead. Most of the soldiers who fought against those T-34s are gone. The Soviet Union collapsed decades ago. The Cold War ended. The world has moved on to different conflicts and different technologies and different fears. But I still carry that moment with me. Still see those shells bouncing harmlessly off sloped green armor. Still feel the sick realization spreading through my chest as the calculations became undeniable. Still hear Guderian's voice speaking words that everyone in that room knew were true, but no one wanted to acknowledge. We have already lost. The mathematics prove it. We just do not know it yet, or cannot admit it, or will not admit it even knowing, because admission would require accepting that we started a war we could not win, and millions will die before that truth becomes official. If I could travel back in time to June 1941 and speak to that younger version of myself, standing in Kummersdorf, watching test results that proved defeat was inevitable, I would tell him this. You already understand. The numbers are clear. The production ratios cannot be overcome. The strategic picture is decided. Nothing you do from this point forward will change the fundamental mathematics. Germany will lose because the Soviet Union can build 5 tanks for everyone we build, and their tanks are better than ours, and cheaper than ours, and more reliable than ours. That combination is insurmountable, but you will not speak this truth. Because in Nazi Germany, speaking truth about defeat is more dangerous than facing enemy fire. So you will write careful reports documenting technical specifications while avoiding strategic conclusions. You will propose solutions that you know cannot work, because proposing nothing would be worse. You will watch production numbers become increasingly impossible while pretending there is still a chance. You will become complicit in prolonging a war that mathematics had already decided, and you will carry that weight for the rest of your life. The factory where that T-34 was built still stands. Nizhny Tagil in the Urals. I researched it after the war. They produced approximately 55,000 T-34s at that single facility, 55,000 tanks from one factory. More than Germany produced total vehicles of all types across the entire war. One Soviet factory outproduced our entire nation. That is not a failure of courage or will or tactical doctrine. That is mathematics. That is what happens when you start a war without understanding industrial capacity. When you assume that technical quality can overcome numerical quantity. When you believe your own propaganda about inherent superiority. When ideology replaces arithmetic in strategic planning. I kept detailed records from those tests. Photographs, measurements, calculations, ballistic data, all carefully preserved, because I thought someday someone would want to understand what happened, why Germany lost, how we went from overwhelming victory in the opening weeks to catastrophic defeat within 4 years. The answer is in those records, in armor thickness and slope angles and production costs and manufacturing time, in mathematics that do not care about ideology or pride or belief, mathematics that simply are regardless of what we wish them to be. That captured T-34 represented mathematical proof that we could not win. We tested it, measured it, calculated the implications, understood the conclusion, and fought anyway because the alternative was unthinkable. Subscribe to this channel if you want to understand how wars are really won and lost, not through heroic charges or brilliant tactics or superior courage, through production capacity and logistics and industrial mathematics, through understanding that sometimes crude effectiveness beats refined precision. That adequate equipment in overwhelming quantity defeats perfect equipment in limited numbers. That wars of attrition are won by the side that can replace losses faster. These are the truths that history books rarely teach, because they are not dramatic or heroic or inspiring, but they are true. And truth matters more than drama. That is what the T-34 taught me in June of 1941. That is what I am teaching you now. Remember it when politicians promise easy victories. Remember it when ideology claims superiority over arithmetic. Remember that the tank which wins is not the best tank. It is the tank that exists in sufficient numbers when and where it is needed. Everything else is just engineering pride pretending to be strategy. And pride does not stop shells. Never has, never will.